students. So this is another example of probability and random variable which is related to the coin toss. So before diving towards our example, we have to see that how many types of random experiments exist. So there are basically two types of random experiments which involve sequential experiments and simultaneous experiments. So what are the sequential and simultaneous experiments? Let's have an example of coin toss. So suppose we have a single coin which we are going to observe through a sequential experiment. So in order to sequentially perform the experiment, we have to toss it 3 times. So let's toss it. Let's say we toss it 1 time, second time, and then the 3rd time. Okay, so this is basically the sequential experiment in which same coin is tossed 3 times. Similarly, there are another type of experiment which is called the simultaneous experiment. In these type of experiments, we have the same coins, but let's suppose despite tossing it 3 times, we toss 3 coins simultaneously. So tossing them simultaneously, we will get it like this one. So and the sample space of these two experiments will be the same. Sample space of the first experiment will be the heads, 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 tail, heads, tail, heads, tail, heads, heads, tail, tail, heads, tail, heads, tail, heads, tail, tail, and tail, tail, tail. All the possibilities which can be observed in both the sequential and simultaneous experiments can be seen here. So keeping the sample space aside, and then now finding the probability of 2 heads in 3 tosses. So in order to find the probability of 2 heads in these 3 tosses, what we have to do, we have to see that how many elements we have in which we have 2 heads. So these are the events where we have 2 heads, 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 tail, heads, tail, heads, and tail, heads, heads. These are the 3 events, and we have to find the probability of the 3 events. So as we know that all the 3 or the elements or all the events in the sample space are again equiprobable. So again, using the sum formula, like the number of elements in this event divided by the total number of elements in the sample space, so we can find the probability like 3 by 8, because the number of elements here are 3 and the total number of elements are 8. Similarly, in order to find the probability of 1 head in 3 tosses, we have to see all the events where 1 heads occur in all the 3 tosses. So what are those events? We can see that these events are tail, tail, heads, tail, and heads, tail, tail. So these are again equiprobable events. So in order to find the probability here, again we have the formula which is the number of elements in the event set divided by the total number of elements, and it is again 3 by 8. Similarly, if you want to find out the probability of 0 heads in 3 tosses, so it will be equal to 1 by 8, because 0 heads just occur in tail, tail, tail event, and as it is the only event, so it will be 1 by 8. And similarly, the probability of the 3 heads in 3 tosses will again be equal to 1 by 8, because here the elements are again 3, and this is the overall example in which we have seen all the events which can occur in any simultaneous or sequential experiment. So I hope it has cleared your concept. I will see you in the next week. Thank you so much. Goodbye.